How traditional kettle works.
What we just know is that when we turn the stove on, at certain times the kettle will have a high-pitched notes from the kettle's nozzle that shows the water is ready. But before, let's go back to the reason why. The heat from the stove fire heat the water inside and cause the water boiling and resulting steam to come out from the evaporation process. As we all know, water's boiling point is 100 degrees Celsius.
Then how about electric kettle? Is it the same mechanisms?
It actually simple. It all relate with thermodynamic. The electricity from wall socket will flows through a heating element in the kettle and cause the water heat up. And then the steams from it will activate thermostat A, cutting off electricity.
A bit more details, please.
Ever wondered how your kettle actually heats water? Let's look inside. Electrical energy enters the heating coil. Resistance turns it into heat, warming nearby water. Heat spreads by convection. Warm water rises, cool water sinks, until the whole kettle nears boiling. When boiling, steam and temperature trigger the thermostat. It breaks the circuit and safely shuts off. Mineral scale on the coil slows heating. Descale regularly to keep it fast and efficient.
Still confused? Let's get back to basic. Conduction is when energy is transferred from hotter region to a cooler region in a substance by the particle vibrating. While conductors are materials which transfer energy easily from a hotter region to a cooler region. Metals are good conductors.
The metal is heated from one end and the atoms in that region gain energy and vibrate. The energy is conducted through the material as the neighboring atoms vibrate. Energy continues to be transferred throughout the metal.
So, which one better?
This slide compares traditional and electric kettles. Traditional kettles use fire as the heat source, while electric kettles use electricity. In traditional kettles, heat flows from fire to metal and then to water, which causes higher heat loss. Electric kettles heat water directly through a heating element, making them more efficient. The added components, such as the heating element, indicator light, and power supply, make electric kettles faster, safer, and more convenient to use.
How about the thermodynamics fundamental behind this?
To understand how an electric kettle works, we need to look at the first law of thermodynamics. This law states that the change in internal energy of a system is equal to the heat added to the system minus the work done by the system, which is expressed as delta U equals Q minus W in an electric kettle. Electrical energy is supplied to the heating element and converted into heat energy. This heat is transferred to the water, increasing its internal energy. As the internal energy increases, the temperature of the water rises until it reaches the boiling point. This process clearly shows how energy is conserved and transformed, making the electric kettle a simple and practical example of thermodynamics in everyday life. This is the empathy and impact reflection for the electric kettle. Understanding how it works helps us appreciate how engineering makes daily tasks faster, safer, and more convenient. It also increases awareness of safety and energy use, encouraging people to boil only what they need and use electricity more responsibly, benefiting both individuals and the community.
In conclusions, understanding how kettles work helps us use energy wisely and stay safe at home. By boiling only the water we need and choosing efficient appliances, we can save electricity, reduce energy waste, and protect our environment. This shows that thermodynamics is not just science in textbooks, but also improves our daily life.
Thank you.